we're talking about the floating point data types. Floating point data types are used to define variables that can hold real numbers. So floating point numbers are basically data types that allow fractional values. The first part of the numbers in our scientific notation is going to be called the mantissa. That's just something for you to note. It's not super important, but what is important to know is that computers typically use E notation. You know how you have like the times 10 raised to whatever you're moving over, like in this example, we have e to the 4, it'd be like times 10 raised to the 4th. But like I said, computers are going to be using E notation typically. In C++, there are 3 data types that can represent floating point numbers. You have float, double, and long doubles. Doubles are typically the standard. So for floats, they're considered single precision. They take 4 bytes. Well, you can use any number between plus minus 3.4 e negative 38. You could also use plus minus 3.4 e to the 38. So it's basically a really huge number or a really small number. Double precision uses 8 bytes, and this is numbers between plus minus 1.7 e negative 308 and plus minus 1.7 e 308. Long double precision uses 8 or 10 bytes, and they use the same thing with doubles, so plus minus 1.7 e, either plus minus 308, but they can also do from 3.4 e negative 4932 to plus minus 1.1 e 4832. So you have a really big range with this long double. Second part of this video is talking about floating point literals. We may want to express this in a variety of ways. One method is RE method, and it's usually stored in memory as doubles. Like I said, if you need to force a literal to be stored as a float, then you can append the letter F to it. So for an example, we'll have 1.2f. That makes it a float. Otherwise, again, like I said, that number will be represented as a double. Sometimes you need to force a floating point literal to a float variable, and this is just to avoid any possible error messages that might come up. If we want to force a value to be stored as a long double, remember we have those as well, we're going to append a L in either uppercase or lowercase, but I always do uppercase just so you know it's a L to the end of it. And it's not going to get it confused with long integers as long as you have a decimal point in it. Otherwise, it will be a long integer. But as long as you have a decimal point, it considers it a long double. If you want to assign floating point values to integer values, you can. You can downcast. When a floating point value is assigned to an integer variable, the fractional parts are going to be completely discarded. In other languages, it's a little bit harder to do so. Not really hard, but you have to do an extra step. In C++, just look at the example here. If we have like int number, and then we have number set equal to 7.5, it's only going to assign 7 to the number. It's going to disregard everything after the decimal. Now, when the value is discarded, it's said to be truncated. We have a larger example. So if we have int I, and we have float f, with f being 7.5, if we assign I to our float, it's still only going to assign 7 to our integer, because integers can't hold decimals. That's going to be it for our whole float section. Next we'll be looking at logic booleans and data type size, and then more about variables. So that'll all be in the playlist linked below the like button.